Hello everyone, welcome to my youth programming club. Today we will be solving another daily Leetcode problem, and the problem's name is minimum number of arrows to burst balloons. Okay, so there are some spherical balloons on a flat wall representing XY plane. The balloons are represented as a 2D integer array points. Okay, each balloon is having a starting x coordinate for its diameter and ending x coordinate for its diameter. Okay, representing its horizontal diameter. It means that what is the stretch of that balloon. Okay, so if a balloon is from 1 to 6, it means that this balloon is stretching like this. Okay, and there is a person standing here who is shooting arrows from this direction below. Okay, so you have to tell what are the minimum number of arrows that this person can shoot so that all balloons are busted. Okay, so you have to tell that. Now moving back towards the problem statement, arrows can be shoot directly vertically up in positive y direction. As I told you, these will be in positive y direction. Okay, it will be y axis and this will be your x axis. Okay, so there is no limit to the number of arrows that can be shot. A short arrow keeps traveling infinitely. Okay, so for example, if this arrow is being shot from here, it will keep traveling infinitely and will not stop with any number of balloons in its way, and it will keep bursting all the balloons that are coming in its way. Okay, bursting any balloon in its path. Okay, so given the array points, return the minimum number of arrows that must be shot to burst all the balloons. Okay, so if this is your input, you have to tell what will be the minimum number of arrows that can burst all the balloons. And let's have a look at the constraints before thinking of our approach. Length of this particular points array, which is having diameter coordinates of each balloon, is of order 10 raised to power 5, and each entry in this points array will be of length 2, having left and right coordinates of diameter of each balloon, and then x start and x end will be ranging from minus 2 raised to power 31 to 2 raised to power 31 minus 1. Okay, so let's see how we can solve this particular problem. So let's take the very first example that is there, this example. So this is the array that is given to you, having coordinates of different balloons. Okay, now what we will do, we will greedily check for the overlap among balloons. Okay, let me write here clearly, greedily check for overlap among balloons. Whenever there will be a overlap, when you shoot one arrow, that one arrow will burst all the balloons that are overlapping. Okay, so let's say the person is standing here and he what for that overlap checking, what we will do, we will sort our points array according to the endpoints of each diameter. Okay, so as you can see that these endpoints are in increasing order right now after sorting. So we will sort this according to endpoints. So once you have sorted the array according to the endpoints, then you will find how many balloons are there that are not overlapping with each other. Okay, or how many sets are there that are not overlapping. So for that, what you will do, you will club all the overlapping balloons into one you can say set, and then you will count the number of set of such balloons which are not overlapping. So as you can see, the balloon from 1 to 6 and the balloon from 2 to 8 is overlapping. This is the region. Let me change color here. I think this color should be fine. Okay, you can see that this region is of overlap. Okay, this is common among these two spherical balloons diameter. Okay, for the first one and the second one. Okay, let's say you decide to shoot a arrow, and that arrow ends up bursting these two balloons. Okay, which two balloons I am talking about? These two. Okay, now this group is gone. Okay, for that, what is the optimal distance for taking down these two balloons in one go? So you can shoot your arrow anywhere from starting from here to here. Okay, so this is the section that will end up bursting both of the balloons, and if you give it a shot anywhere else, only one of the balloon of these two will be bursted. If let's say the person is standing here, and instead of this one he decided to shoot the arrow from this direction, and he end up bursting which two balloons. Let me change color again. These two balloons. Okay, but you can see, what about this balloon? This balloon will be remaining unaffected, because these two are already gone and there was no common overlap between these two and this third one. Okay, so that's why we will be only interested in the region which is common to both of the balloons. Okay, so this is the common region, that's why we are only interested in common region. So let me change color again. So this region is the common region in the overlap that we are interested in. So we have to find out these common regions. Okay, more the number of common regions, lesser the number of arrows required. More the number of common regions, or more larger is the common region, lesser is the lesser are the number of arrows required. Okay, so as you can see that one common region resulted in only one arrow being used for bursting two balloons, and let's say it would have been the case that 3 of or 4 of the balloons were having this common region. So you can see, when the person will be standing here, he can just shoot this arrow and it will result in ending bursting these 4 balloons, okay, that were there. Okay, 1, 2, 3 and 4. So we are only interested in finding this particular overlap. So for that, what we can do here? So what we can do is, this problem is quite similar to merge intervals problem, if you are familiar with it, or you have seen my video from today's part. Okay, but anyways, I will be explaining here also. So to find this common region among two intervals, what we will be doing is, we will be taking x coordinate which is having maximum value in the left. Okay, among the left two parts, what is the maximum value? 2 here. Okay, so we will be taking this part, okay, which was 2 among 1 and 2, and for the right part, or to be specific, this part, we will be taking minimum value. Why we are taking minimum value? Because we are interested in finding only the common region, and it is this is the only way with which we will be able to find the common region. So we will be taking minimum, and it will result in giving us this common region, okay, this region. So that's why for the left parts, for the left coordinates, we will be taking maximum of the those two, and for the right coordinates we will be taking minimum, and that's how we will find out the common region. And we will count such common regions which are not overlapping. Okay, count common regions. Or you can say intervals which are not overlapping. So how many of them are there? There are only 2. As you can see, this is also a common region between these two coordinates, and as you can also observe here also, that for this particular part we have taken the maximum. So maximum value was 10 here, and for the last part, or the right part, we have taken the minimum. Okay, this is the minimum. So this is another common region, and these two will not be overlapping. So we require at least 2 arrows to burst all the balloons. So one of the arrows should be shot from this particular region. Okay, and it will end up bursting all the balloons. So let's see how we can do this programmatically. This part was clear, I guess. You should be sorting according to the endpoints, okay, in increasing order. And then once you are done with it, what you can do is, you can have a stack. Okay, so we will be having a stack value, and since for the very first interval that is there, this is interval 1, 2, 3 and 4. For the very first interval, there is no interval previous to it, so we'll be pushing this interval into the stack. Okay, 1:6. Then let's say you are at this particular interval, you are traversing the intervals from left to right direction. Okay, so your intervals array will be looking something like this: 1, 6, then it will be 2, 8, then it will be 7, 12, and then it will be 10, 16. Okay, so you will be traversing it into left to right direction. First of all, there is no interval before this interval, so you will be pushing it into the stack. Okay, this will be the stack that you will be having, or you can say point stack. Okay, so then let's say you are at this particular interval while traversing this array from left to right direction after this array is being sorted according to the endpoints in increasing order. Okay, so you will check for the overlap. How you will be checking for the overlap? Let's say this is the previous interval. Okay, and this one is the current interval. So the condition of overlap is that end previous end should be greater than or equal to current start. Okay, only then there will be a overlap. Okay, this is the condition for overlap. Okay, so you can observe from your side also that let's say these are two intervals represented on x-axis. Okay, this is the previous end and this is the current start. So you can see overlap will only exist when previous end is greater than or equal to current start. Okay, so that's why this is the condition. Okay, let me write it more clearly. I think it is not that much clear, so sorry for bad handwriting. Previous end. Okay, so this is the overlap condition that we will be checking for, and previous end was 6 here and current start is 2. So previous end is greater than current start, so there is a overlap indeed. And what we will be doing is we will be updating our current end and current start values. Okay, so how will they be updated? According to this scheme, max and minimum scheme. Okay, so current start will be, let me bring it to another slide. Current start will be nothing but minimum of we will be doing these two operations whenever there is a overlap. Okay, overlap exists. So current start and not minimum, we will be taking maximum actually. Okay, so as we discussed, let's that for the start part we are taking maximum values and for the end part we are taking minimum values. So maximum of current start and previous start. Okay, and current end will be nothing but minimum of current end and previous end. So what these two operations will give, this will give us the common region. Okay, this region will be given to us with the help of these two operations. Okay, these two operations, so it will give us common region. And once you are having this common region, and overlap is no longer existing or your stack have become empty, either of these two conditions are there. Okay, so there was a overlap, so you will keep this out of the stack and pop it out. So now the current start and current end values are having values of current start is equal to, as of now, 1. Okay, since we were taking maximum of 1 and 2, okay, these two, and current end is nothing but minimum of these two, okay, which was 6. So we will be, you know, pushing 1 6 into the stack, and then we will be coming to the next interval that is there, which is 7 12. Okay, actually I have done a little mistake here. Instead of 1 6 it will be 2 6, because you know current start was the maximum of 1 and 2, so it will be 2 6 here. And then you are at 7 12. For 7 12 you may see that there is no overlap, okay, because you know current end is less than current start. Okay, this is your current start as of now. So what you will do, you will just push it into the stack 7 and 12. Then you will come to this particular interval, this interval 10 6, and this is your current previous end and this is your current start. As you can see that previous end is greater than current start, so there is a overlap, and you will be finding the common region by taking this value out. Okay, so for the common region it will be 10 12, as you can see here. So we will be pushing 10 12 into the stack. Okay, so at last your stack will be having two values. One will be 2 6 and another will be 10 12. Okay, these two values we are talking about, and 2 6 from this side. Okay, so whenever you will be shooting your value arrows from these two positions, all the balloons will be bursted. So the minimum number of arrows will be nothing but size of this stack size. Okay, so this is what you will be returning, and this is how you will be solving this entire problem. I know it's a little bit messy, the space was less, but I guess you would have been able to understand and grasp the approach that was required to solve this particular problem. Now let's see the implementation part. Okay, so these are just for debugging purpose. I am removing it. Okay, here what we are doing is we are sorting your interval points array into according to the endpoints in increasing order. Sorting points array according to endpoints in increasing order. Okay, so why we are doing so? Because we want to find out greedily the overlaps that are existing. Okay, and once we have done it, what we will do, we will be using our point stack. Let me rename it. Okay, then this stack will be used to find the common regions or intervals which are not overlapping. Okay, and first of all, since for the very first point there is no point previous to it, so you will be pushing that point into the stack. Okay, for the very first point. Okay, by point I mean coordinates of diameter of the very first balloon. or you can say for the very first balloon. Okay, there is no balloon on left hand side of it, so we are pushing it to the stack, or its coordinate to be specific, x coordinates. And then you will be doing a linear traversal of your points, sorted points array. Okay, you will be taking the values of current end and current start, and this will be the condition for overlap. Okay, this is your previous end. Okay, and whenever your previous end is greater than the current start and your stack is also not empty, then you will do these two operations. Okay, you will be taking the value that is on the top of the stack and doing these two operations to find out the common region. Okay, here we are finding out the common region. And then once we are having the common region, we will just simply, after that, after there is no overlap existing, we will just push the common region into the stack. Okay, or even if there is no common region, then we will be pushing your current interval. Okay, and then simply you will be returning your size of the point stack, and this much number of arrows will be required at least to burst all the balloons. Okay, so I hope you were able to understand this particular approach and why sorting was required, why we were taking maximum here and minimum on this side just to find out this common region. Okay, and that is how we will be solving this particular problem. And as far as time and space complexities are concerned, time complexity wise, as you may have guessed also, since we are doing a linear traversal only, so let's say the points array was having a size of n, then it will be order of n, since we were doing only a linear traversal. Okay, not actually order of n, I did a mistake here, because sorting is also involved in this particular thing, so it will be order of n log n. Let me write it clearly, n into log of n, because of sorting. Okay, and for space complexity, as you can see that at max it will be of order n, since we are using this stack to store the points. Space complexity wise it will be order of n. Okay, so these will be the complexities. It will be because of use of stack. Okay, so, and yeah, if you are still having any doubts or any queries in general, then you may ask them in the comment section. Thank you for watching. Have a great day ahead.